So how the blockchain will be stored and what are the features about the blockchain? The blockchain will be automatically stored inside the P2P network. For example, this is one network. So here is one peer, here is another peer. It's a collection of a number of peers. A peer or node is equal to a device on the network. Assume there are 4 devices here. And automatically the blockchain will be distributed over the P2P network. So that means these are the connections and the blockchain will be automatically distributed over the network. Means at every node the copy of the blockchain will be maintained. The blockchain is a collection of blocks connected each other. Every block contains reference to the previous block and a block doesn't contain the reference to the next block. The features of the blockchain are like this. First, it is supporting peer-to-peer network. It doesn't work on other types of networks. It is mainly meant for peer-to-peer network. Peer-to-peer network is also called as node-to-node network. A node is a device on the network and every device will have its own copy of the blockchain. Same blockchain will be duplicated at every node. And there is no need of taking any permission from the any centralized authority here. There is no any server or there isn't any centralized authority to organize all these things. So all the nodes are having equal priority or equal importance. So any node can enter into the network and can take the can take the data from the blockchain. And the second feature is about it is decentralized. This blockchain is completely against to the principle of the centralized mechanism. Presently, most of the websites or organizations are centralized mechanism. For example, the banks or any website, Gmail, Facebook, any website, all these are working based on the concept of centralized. So there will be one server and a number of clients will be there. The server will store the information and the clients can get the information from the server. So this blockchain is completely against to that policy. So here that in the blockchain, the data will be stored at every device or every node. So there is no need of any organizing any centralized authority here. That's for the decentralized. And next one, immutable. The meaning of immutable is the data can be entered into the network but cannot be modified or deleted. The data that is stored in the form of a hash inside a block cannot be modified, cannot be tampered. Only data entry is there, exit is not there. The reason for this feature is, suppose we have modified some data in this particular in this block number 2. In case if you modify this block number 2, the block number 2 hash should be regenerated. Once the block number 2 hash is regenerating, the same hash is to be stored in the block number 3 and the block number 3 hash should be regenerated and based on that block number 4 should be regenerated. Like this, if you modify the data of one block, by design, by definition, all the subsequent blocks needs to be recalculated or regenerated. That is practically impossible. That's why we got the feature of immutability. But if you compare with the regular database management systems, in the regular database management systems, any record can be updated or deleted without affecting other records. But that feature is not there in the blockchain. So we can trust the technology that it should not be modified, should not be deleted. Okay. So in that way it is immutable. Immutable means read only. We cannot modify. Once the data entry done, but it cannot be modified. That is the meaning of immutability. Next, no hacking. So it's highly impossible to hack this blockchain because generally hacking people, hackers will try to hack a particular part of the data, maybe suppose a particular block, maybe it's a particular block. In case if you want to hack the blockchain, all the other devices we have to hack. For example, the second block, if you want to modify second block, third block, and all the subsequent blocks, at the same time, all the subsequent blocks of all the nodes we have to modify. If a network is having some hundred or thousand nodes, all the blockchain needs to be updated means it's highly impossible. So overall, hacking is not possible in case of blockchain. But in case of regular centralized mechanisms, it is only enough to hack the server. So server itself is a single device. So it's maybe possible to hack the single device. But here we have to hack all the devices. That's highly impossible. And another feature, data availability. The meaning of data availability is like, for example, in case of particular node is, crashed, operating system crashed or hard disk crashed, or some any disaster happen in case of one particular node. But no problem because the same data is available in all the remaining nodes. So even though one or two nodes are getting crashed from the network, not a problem because all the remaining nodes are having the same data. We can easily get back the same data from the other nodes. So there is a safety or there is a guarantee that the data will exist, will never lose. These are the 5 different features of the blockchain. Blockchain has 3 versions: blockchain 1.0, 2.0, and 3.0. Blockchain is not a software and blockchain is not a language or package. No one is making the blockchain software. Blockchain is a technology. So whenever any breaking changes happen in the technology, that we are assuming as a new version. So blockchain 1.0 has started in 2009 and till 2014 it was the first version. In this first version, the blockchain stores only financial transactions, only online money transfers. Suppose I'm paying some money to you, you are paying some money to me. So only this type of financial transactions are being stored in the blockchain 1.0. For this example is Bitcoin. Bitcoin, Litecoin, these are all examples of the blockchain 1.0. So it's only meant for which one? Financial transactions. It's not for any other purpose. Now coming to the blockchain 2.0, which is started in 2015 up to 2017. Now this blockchain is not only it's not end of the 2015, maybe suppose present also you can say. Not it's not end with the 2017. Okay, so from 2015 to present, blockchain 2.0 does exist, and a blockchain, in this case of blockchain 2.0, the blockchain stores financial, non-financial transactions, also. So financial, non-financial also it is able to maintain. Financial means the money related transfers or something. Suppose the payments, transfers, etc. But non-financial means suppose some voting systems you want to store. Suppose you want to store some, what you can say, sales information you want to store, or company accounts you want to maintain. Otherwise, personal contacts information you want to store. Otherwise, online documentation related software details you want to store. when which data is updated, who is updating which data, etc. Otherwise, you want to store the details about the land registration. So these are all examples of the non-financial. The non-financial transactions also can be stored in the blockchain. That is a major difference between the 1.0 to 2.0. So presently there is a huge demand for non-financial, because only financial means very limited cases only it is applicable. When it comes to non-financial, for any scaling, for a maybe large scale data or small scale or medium scale, for any scale, the blockchain is applicable. So that's why the huge demand is increased for blockchain because of non-financial transactions. So that is the present job source, that is non-financial. And blockchain 3.0 started from 2017. So presently we are in the 2.0 and 3.0. Both are uh, presently in usage. So when it comes to blockchain 3.0, here blockchain contains private information of a group of organizations. For example, we are having three organizations. We form one alliance, and we are going to maintain our data ourselves within our company premises only. It's not a public network. So this type of data we are able to maintain. So for this example is a hyperledger. For blockchain 2.0 example is Ethereum. In Ethereum, we are able to maintain financial and non-financial transactions also. But in blockchain 3.0, hyperledger is able to maintain. Hyperledger means we can store the set of blockchain related information we can store that is related to a few organizations. Here is the best example, what I can say, supply chain management system. Means starting from the materials, raw materials is being prepared in some factories. Those are collected into some manufacturing unit. It is making one product that is given to a different distribution company. The distribution company distribute the products to different retail or online stores, and the customers are purchasing the items from the retail stores. So the complete information we are able to track in a single data store. Presently at this situation, different organizations are maintaining their own database. So synchronization problems may occur. Tracking the particular item which is manufactured by different companies may be difficult. So to organize all together, we are maintaining a common database. That common database is what blockchain. So that is the intention of the blockchain 3.0. So presently in the market, blockchain 2.0 and 3.0 has huge demand. Even the blockchain 1.0 does exist like Bitcoin. More development scope is exist for blockchain 2.0 and 3.0. Our current codes focuses on the blockchain 2.0, and there is a next advanced blockchain codes available. That codes will cover the hyperledger also. That is a blockchain 3.0. So anyway, we have to focus on the blockchain 2.0 in this course, that is Ethereum. So we should be able to maintain financial and non-financial transactions also. Any type of data should be able to maintain in this case of Ethereum. And there is one more point I missed here, that is smart contracts also we are able to maintain. In the blockchain 1.0, no smart contracts, but in the blockchain 2.0, smart contracts are able to maintain. Smart contracts are like the programs that are executing based on the blockchain. It is able to persist some information. It is able to do some process or logic based on the existing data. We can check like if the data is operated like this, if these inputs are provided, then these particular processing should be done. For example, the company wants to provide some salaries to all these employees automatically at the end of the month, at the day 30 or 31, automatically the monthly salary needs to be paid to the employees based on their pay scale and as well as their number of hours they worked. automatically the salary should be calculated and the payment needs to be done. That can be automated here. So this type of user-defined processing can be done by the smart contracts. So these are the versions of the blockchain.